chapter 4 is Alkanes, but it also has all of the beginnings of nomenclature or the naming rules of organic chemistry as well. So the place to start with naming is we need to know the 10 prefixes for molecules with 1 to 10 carbon. So we'll start with 1 carbon. So here I'll have my number of carbons. And here I'll have the name. And then over here I'll have a structure. So 1 carbon is called methane. And the structure, we can't actually draw a skeletal structure for methane because it would just be a dot. And that wouldn't make any sense to anybody. So methane, so it's CH4. Right, if I have 2 carbons, it's called ethane. And I'll draw, let's see, a condensed structure of this one, CH3, CH3. So that's ethane. If I have 3 carbons, it's propane. And now I can start to draw skeletal structures. Because again, this skeletal structure here would be a dot. This one would be just a straight line that's not really obvious what you're doing. But once we get into 3 carbons, then the skeletal structures make more sense. 4 carbons, it's butane. At 5 carbons, it's pentane. At 6 carbons, it's hexane. And now some of these make sense. Some of them, I think, methane, ethane, propane, butane, you probably just have to memorize what the order is. But pentane, like the pentagon, so it's 5 sides. Pent means 5. Hex, like a hex wrench or a hexagon, I'll have 6 sides, so that's 6. So those ones, I think, are reasonably obvious. I'll just continue over here. 7 is heptane. 8 is octane. And we're probably familiar also with octagons. 9 is nonane. And 10 is decane. And again, hept is a little bit different than sept, but it has that same sort of idea for 7, oct for 8, non for 9, dec for 10, like the decimal system, which is a base 10 system, or a decade, which is 10 years. So dec always is 10. When we're going to talk about carbons and hydrogens, we need to be able to have language that helps us explain what type of carbon or what type of hydrogen we're looking at. So first of all, if we have a carbon that's bonded to all 4 hydrogens, that's called a methyl carbon. And it's not really a class because there's only one example of it, methane. However, if the carbon is bonded to 1 carbon and the other 3 bonds are to hydrogen, then we have to have a new name for this. And so what we call this carbon is we say that it's primary. A primary carbon is bonded to 1 other carbon. We would write it 1 with a 0 after it. A carbon that's bonded to 2 other carbons and 2 hydrogen is called secondary. And we write that with 2 with a 0. A carbon bonded to 3 other carbons and only 1 hydrogen is tertiary. 3 with a 0. And a carbon bonded to 4 other carbons is called quaternary. Or 4 with a 0. Now we can do the same thing with hydrogen. And we can talk about types of hydrogens. So the accompanying hydrogen here would be a methyl hydrogen. It's just a hydrogen on methane. A hydrogen attached to a primary carbon is a primary hydrogen. A hydrogen attached to a secondary carbon is a secondary hydrogen. A hydrogen attached to a tertiary carbon is a tertiary hydrogen. And there are no hydrogens attached to a quaternary carbon, so you cannot have a quaternary hydrogen. So all the structures that I drew in the beginning were all acyclic structures, or structures without rings in them. You can also have cyclic structures of alkanes. So the rules are pretty much the same. If I have 3 carbons in it, 3 carbons would be propane. But if it's in a ring, then it's cyclopropane. If I have 4 carbons, that would be butane, so that's cyclobutane. If I have 5 carbons, that would be pentane, so this is cyclopentane. If you had 6 carbons, it would be hexane, so this is cyclohexane. You can do this with any derivatives of these molecules as well. You could name it at the base as cyclohexane, and then other things that are coming off of it.